Hopefully this review for your Chapter 6 and 7 test will be helpful. First question, what is the exact value of tangent 5 pi over 3? Now, the first thing you want to do when you see 5 pi over 3 is you want to find 5 pi over 3 on the unit circle. So 5 pi over 3 is 1 2/3. So 1 pi and 2/3 is right down there. To get tangent, you have to know that tangent is y over x. So when you look at this coordinate here, 1/2 over down square root 3 over 2, it's going to be y divided by x. Y divided by x. And when you divide, you flip the second one. See how I flipped the 1/2, make it 2 over 1, and multiply. Then, before I multiply straight across, I'm going to try to cancel these because those eliminate, because 2 over 2 is 1. They disappear. And then I'm left with this divided by 1 is negative square root 3. So negative square root 3 is the exact value of tangent 5 pi over 3. First step, find this. Second step, know what tangent is. Since tangent is y over x, you have to do some math. Tangents are the hardest of the trig functions to find values for. Number 2, moving counterclockwise along the unit circle, in which two quadrants would the value of tangent be positive? So here's my unit circle, quadrant 1, 2, 3, 4, and we're going counterclockwise. It's wondering which is tangent positive. For tangent to be positive, remember tangent is y divided by x. So in this quadrant, every coordinate, when you take y divided by x, in this quadrant, you should realize y and x are both positive. So when you take a positive divided by a positive, it's going to stay positive. So quadrant 1 is one where it's going to be positive. Over here, your y's over your x's. In this one, your y's are always positive because you're always going up, but your x's are negative because you went left. So you went negative x up y. So when you divide this, you're going to get a negative, which is not what we're looking for. Down here, your y's are negative, your x's are negative. When you take a negative divided by a negative, that becomes a positive. So that is why we have quadrant 3. And the last one, you go x positive but y negative. When you divide those, you're going to have a negative value. So tangents that are positive are in these two. If I want tangents that are negative, it's in these two. And then also be aware of what if I said the word sine or cosine. Think about what quadrants would your sines and cosines be. Tangent is you're taking y divided by x. Sines and cosines is a little bit different, but it's still got a very similar question on that. Number 3, let's convert 100 degrees to radians. The way I convert degrees to radians is I first start with the idea that pi is always equal to 180 degrees. Remember on a unit circle, pi is half circle, and 180 degrees is also half circle. So then I make a proportion, and I put 100 degrees under my degrees, which is 180. And over here, if I put x here, that's my radians. So to convert, well, I have a proportion of radians to degrees, I know a degree, so I want to find the radian that matches 100. And this is called a proportion. And how do we solve a proportion? We cross multiply. So these two multiply, give us this. These two multiply, give us this. And how do we solve for x, which is the radian measure that matches 100? We divide both sides by 180. Then, to simplify this, those cancel, and then 10 over 18 reduces to 5/9. So 5/9 pi is what that one would be. All right, problem number 4 here can be a little tricky, because which of these expressions has the same value of sine negative 11 pi over 6? First thing you have to do is find what is the value of sine negative 11 pi over 6. So first step is actually, out of all that, is first do negative 11 pi over 6. Well, negative 11 pi over 6 is negative 1 5/6 pi. So this is negative 1 pi, and negative 5/6 takes us all the way around to right there. So this right here is negative 11/6 pi. All right, it's also 1/6 pi if you come this way. All right, so what is sine at that point? Sine is your y value, so my y value of sine of it is 1/2, my y value there. Okay, so I'm looking for 1/2, so which of these is 1/2? So we have to go one by one and figure it out. So if you look over here, I found out that cosine 2 pi over 3, b, is what we're looking for. And let's show you why the other ones don't work. And we'll leave b as last to show why it does work. So for this one, if I want 11 pi over 6, and I want sine of 11 pi over 6, well, 11 pi over 6 goes the opposite direction all the way to here. And right there, so that would be, what would that coordinate be? Well, the coordinate right there, if we go all the way around, would be right to there. That coordinate right there would be over square root 3 over 2, but down 1/2. And what I want is, I want positive 1/2. And what is that? Negative 1/2 for sine. So that looks close, but it's negative, so that's not it. If I go to this one, I want pi over 6. Well, pi over 6 is that line. Boom, so we got it. But I want cosine. But the cosine at that point is that. It's the x. And that's not what we're looking for. We're looking for 1/2, so cross that one out. So what we have here is these are both going to cross out. All right, come back to that one because we said that's the answer. This one, 5 pi over 3 is 1 2/3 pi. So if I do that, I got 1 2/3 pi. So 1 2/3 pi is down there. And that coordinate right there is going to be 1/2 comma negative square root 3 over 2. And when we look at that, well, let's see, cosine is going to be the 1/2. Yes, we got it, 1/2. But there's a negative there. The opposite of 1/2 is negative 1/2 again, which isn't the right one. So we cross that one off. All right, so let's prove that this is actually the answer. So what we do is we go 2/3 pi. All right, so 2/3 pi is, let's see, 2/3 pi would be right there. We got it right there. There's a coordinate. And 2/3 pi, I want the cosine. So cosine of 2/3 pi is right here. Oh, we want positive 1/2. The opposite of negative 1/2 is positive 1/2. So that's why. It's very tricky. You got to watch for these negatives. And you got to find 4 different trig functions just to get one answer. So this is going to take a little bit of work, this problem here. And you have to make sure crossing out each one by one. For number 5, the coordinate point this, which if you look at the unit circle, is negative square root 3 over 2 down 1/2. All right, so what standard position angle on the unit circle from 0 to 2 pi corresponds to this? So hopefully you can see it goes all the way around to there, which would be 1 pi and 1/6. So 1 pi and 1/6 is 7/6 pi. Now if this was degrees, you'd be 180 plus 30 more. So 180 plus 30 more is 210. So if it was degrees, you do that. But this, I think it's wants it in radians. Because it doesn't say radians, but I'm pretty sure it wants radians for this problem. So for number 6 here, for which radian measure x on 0 to 2 pi, meaning around the unit circle once, will tangent be undefined? So tangent is undefined right here when you divide by 0. So where is the denominator 0? Well, you have to remember tangent is y over x. So we would look basically as on the unit circle, where is x 0? And if you look at it, there and there are the 2 spots that x are 0. So these 2 spots would be something over 0. Okay, so tangent is undefined when cosine of x equals 0. The denominator equals 0, which are these 2 spots. And what is the radian measure for those 2 spots? Well, this is 1/2 pi, and this one is 1.5 pi. So 1/2 pi and 1.5 pi is 3 over 2 pi. Number 7, I want to convert pi over 8 radians to degrees. So remember here, you always do pi equals 180 because pi is equal to half a circle, 180 degrees. I put this as my radian under my radians, and over here I want my degrees under my degrees. Cross multiply. Now when you multiply this, remember, you're multiplying these two, so you want to put a 1 underneath the 180. And here I always like to reduce before I go any farther, and hopefully you know that 4 goes into both these, leaving 45 and 2. So when I get this, now I have pi still, but 45 divided by 2 is 22.5. Then you divide the pi off, so 22.5 degrees is pi over 8. This next one we're solving. This is where it gets a little long, probably the longest question on the test. In order to solve an exponential, sorry, I said that wrong, a rational equation, you need to find the denominator. You basically need to multiply each piece by the denominators, but you want to find the smallest one, meaning I don't want to multiply by all three of these denominators, because what I noticed with these two denominators, they're basically the same thing. If I multiply by y, okay, that works, but why multiply by 2y as well? Because doesn't 2y have y in it? So I can just do 2y and y minus 25. So I'm not going to multiply by y because y is inside of 2y. I know there's a y inside of y minus 24, but that's completely different. This y, when you add or subtract, that y can't kind of be touched. But this one, y is inside of 2 times y. So all I need to multiply by is this one and this one. So here in red, you see that? I multiply by y, 2y, and y minus 24 by both pieces here in red, all 3 pieces. And I left these one by one. So right here is there, this goes right here, and this goes right here. And I multiplied by the denominators. Again, you could have multiplied by this y, but there's redundancy, so you don't need to multiply that and that. It would just make your problem a lot harder. So you want to go, it's called the lowest common denominator. Okay, these two are the lowest common denominator. Okay, now what we do is we notice that the y will cancel, leaving you that times that is negative 10, leaving that. Here the 2 y's cancel, leaving you this. And here the y minus 24's cancel, leaving you those two, which is 14y. And now all the fractions are gone. That was the point of multiplying by the lowest common denominator. Now we got to distribute, got it right here. The 14y is still over here. Now we're combining the numbers and combining the y's. Okay, then to solve for y, we add the 7y over. Okay, get 21. And we divide by 21 and we get 8. So my answer is 8. But just check for extraneous. Does 8 make that 0? No. Does 8 make that 0? No. Makes that 16. Does 8 minus 24 get 0? No. So that is an okay answer. It's not extraneous. My restrictions on this problem are 0, 0, and 24. And that is none of those restrictions. So we're good to go. Number 9 here. If 40 degrees is a reference angle, then what are 3 other corresponding angles from 0 to 360, meaning all the way around the unit circle, and sketch the angles on the unit circle. So here they are. I sketched all 3 angles. First of all, I sketched 40 degrees. So 40 degrees looks something like that. So then, from there, what you should notice is, well, if that's my reference angle, I want that same looking triangle coming off the x-axis. So if I reflect it over, that would be the corresponding triangle. So what is that angle? Well, I want it to be 40 degrees off the x-axis. And if this one right here is 180, what's 180 minus 40? It's 140. Now, I can also, another reference angle would be the reflection over the x-axis here. So this is 40 degrees down from 180. So if I add 40 degrees to 180, I get 220. So that's another corresponding angle to this reference angle. The last one is if I reflect this over this way. So if I reflect it this way, okay, I got another 40 degrees right here. And so how to get 320? Well, the whole thing's 360. What's 360 minus 40 would be 320. So those 3 are my corresponding angles. You just got to remember this is your reference angle. And the rest have the same looking triangle off the x-axis. Think of 40 degrees off the x-axis, 40 degrees here, and 40 degree here. Let me kind of write it. That'd be 40 degrees there, that's 40 degrees there, and that's 40 degrees there. That was really bad handwriting, sorry. And that's kind of how you get your corresponding angles. Alrighty, problem number 10 here. Identify the restrictions on the domain of this. The way restrictions to the domain are values that would error this. So what errors a fraction is when the denominator equals 0. And how do I get the denominator equal to 0? Well, if this is 0 or this is 0, when they multiply, the denominator would become 0. So we don't want this to be 0, nor do we want this to be 0. So all I do is I say, okay, what would make this 0? And I don't want it. So solve it, I get -1. -1 is a restriction. It would cause a 0 right here. So what would make a 0 right here? Well, I set it equal to 0, or it does not equal to 0. And when I solve that, I get 2. So if I plug 2 in here, I get a 0. If I put -1 in there, I get a 0. Either one of those would be called restrictions, and they would not work if you plugged them in. You'd have an error if you plugged it in. Number 11 is the thinker. You have to really think about this. If a 30-centimeter diameter wheel made one full revolution, then how far did it travel? So for this problem, you have to think that one revolution is 2 pi radiuses. You have to go back to understanding what a unit circle is. Okay, a unit circle, what a circle is doing is, what you have to understand, a radian, what a radian is, that's my radius. So I have 1 radius, 2 radius, 3 radius, 4 radius, 5 radius, 6 radius, and a little bit more. Do you understand that 6 and a little bit more radii is 2 pi radiuses? So one revolution is 2 pi radiuses, or 6 and a little bit more radiuses around. So if my radius, by the way, is 15, because half of 30 is 15, wouldn't there be 2 pi times radiuses? And there's 15 radiuses, so wouldn't that be 2 pi times 15? Because I have a 15 radius length, and I have 2 pi of them, or 6 of them. So my answer would be, multiply those, 30 pi centimeters, which is about, if you want to approximate it, it's about 30 times 3.14, which would be about 90 to 100 centimeters. That's kind of a long ways. So one revolution of a wheel would go almost 100 centimeters if the diameter was 30 centimeters. Again, remember, a radius is a radian. To get all the way around a circle is 6 and a little bit more, or 2 pi radians, radiuses. And if you know your radius, you can figure out how far one revolution of a tire goes. Last question, how do you solve this rational equation? Well, this is called a proportion, so you just cross multiply. This times this times this. Distribute the 2, multiply them, minus over, basic solve, there's your answer, D. Oh, not D, I messed it up. Is it D? Oh, I chose the wrong answer. How dumb am I? What I made the common mistake. This is not D. Let's fix that. The answer is what? Not D. It is A. There's my answer. Be very careful. On the test, you have to watch out for that. See that little line right there? That's a negative. That's a positive. Those little negatives kind of get lost, and I missed it myself. So the answer is actually A. So be very careful. There's the answer. Good luck on the test.